Hashing is a technique of storing data for faster data retrieval. It is basically a data structure that facilitates the retrieval of data in a faster way from a set of large data. Because of the fast retrieval nature of the data structure, it is used in many applications such as maintaining or indexing records in a DBMS system, the accessing tables used in the compiler design, and many more. In this video, we will explore the concept of hashing, also known as hash table, in terms of its implementation, its advantages, and how this hashing technique enables us to retrieve data in fastest possible way. To understand the advantages of hashing table or hashing technique, let us take an example. Suppose we have an array of strings. The array comprises of 9 strings starting, they are stored in locations 0 to 8, and the name of the array is str. So str is a two-dimensional array where we store 9 strings. We store 9 strings. We want to find any given word. Let us say Hiru, Hiru. We want to find whether this Hiru, the given word Hiru, is present in the array or not. To search the given string Hiru, what we need to do, we need to search each and every location of the array and to check whether this Hiru is present or not. So for that, we are writing an algorithm. We are writing a small code segment to find the given word. Say star s is a pointer that points to the given string, and for each and every element in the array, we will compare that given string Hiru with the elements stored in the array. So once we have a match, that means the Hiru and the word stored here in the array is matched, it is considered as the content is found. So here, without using hash table, we have stored the data in normal array, and the search time required to find the element, or here find a word in the array, it needs the time order of n. Because if I see, this loop comprises of one statement, and this loop executes for n time. So that's why it takes n times, where n is the size of the array. So that's why the time complexity of this algorithm is order of n. And this is a linear search, and order of n search time is a big time, and that is not always good, specifically when the value of n is very high. Let's say 10,000, the search time is considerably high. That is why we need some technique where the search time will be reduced to considerable extent, preferably to order of 1 or something smaller than that of order of n. So here the hashing technique comes into picture. If we use the hashing technique, then certainly the search time will be much lower than that of order of n. As we can see, without using hashing technique, when we store data in this array str, what we do, the word Rama was entered first. That's why we have stored in the first available location in the array. Then Hiru is entered, and then we store it is in next available location, that is 1. So this is the process which is used to store data in an array, and we are not using any hashing technique in this case. Now let us suppose that we want to use the hashing technique in order to store this data in the array. so that we can retrieve the data in a fastest possible way. Now in that case, what we need to do, whenever we get one word to store or any string to store, we do not directly store it in the available location in the array. Instead of that, for every incoming or for every input string, we convert this string into a number pertaining to any one of the index given here, and that is called a key. That means we will use a function. That function will take this input string as the input data or argument, and it will generate one number, and this number belongs to any one of the available index of the array. There are 9 different indexes in the array, so it should be from anything from 0 to 8. Then the incoming string Rama will be stored in the location denoted by the key. That is, it will be stored in the location denoted by str key, where key will be the index. So how it will help to retrieve? Suppose again I want to find where is this string Hiru present in the array. So what I will do, first of all, I will generate the key for Hiru. Let us say it generates the number 1, that becomes the key, and I will directly go to the location str1, and we will try to compare that available string in that location, and we'll find that this element is available in that location. So it gives you the search time of order of 1, unlike the previous one where we have stored data without using any hashing technique. It gives an computation time of order of n, but here in this case it gives order of 1, which is a constant time, and this is much better than that of the linear search. Now let us see how can we generate the key from a given string. For generating the key here, what we are doing, first of all, we are taking the ASCII value of each character of the string, then we sum up, then we take the we use the modulo operation with total number of locations in the array. Since there are 9 locations, so total sum of all ASCII values of the first string Rama is 385. Then I'm taking the mode of 385 with 9. So 385 mod 9 is equals to 7. That's why we have stored the word Rama in location 7 of the array. Similarly, we also have computed the ASCII value of each of the characters in Hiru. We add it up 408, then take the mode with 9, that gives 3. So Hiru will be stored in location number 3. So this is the element stored in the array using the hashing technique or hash table. Here the function for computing the key is the sum of all ASCII values, all characters, then modulo of total number of locations in the array. So that key will decide where to store that particular word or particular string. So now suppose I wanted to find the word Vicky, then we will try to find out the key for Vicky. Then that key, since I will add all the characters, ASCII values of all the characters, and that will lead to the key 5, then I will directly go to location 5, and here it is. So here the search time for this word is order of 1 because we need to compare only once. So this is a very small example that we use to store strings in an array, but practically this hashing technique used in many other complicated scenarios like the databases. Next, let us see how this hashing technique helps to retrieve data from any database system. For that, we'll take an example of a database where there are 9 records stored, and these records comprises of different attributes such as the employee ID, first name, last name, phone number, hire date, job details, and salary. And we want to, if we do not apply the hashing technique or hash table, normally we need to search each and every element, every record in the given database in order to find a specific record. Suppose that we normally search the record in terms of the employee ID with respect to employee ID. So employee ID here works as a key to search records. Suppose here I wanted to retrieve the information of employee ID 109. Then I have to go to each of the record in the database. Then I have to compare the employee ID with the given number 109. Whenever there is a match, we will retrieve the data. Definitely this is a sequential searching of records and it takes order of 9. And in case of a database where there are thousands and lakhs of data, order of n is considered as a very high time, and that is not considered as an efficient searching technique. So we can improve the search time by using the hashing technique here. In this case, what we will do, since there are, I'm assuming that there are 9 records, and we have an array of 9 locations 0 to 8, and I will use the mode operation. I will take the employee ID and then the number of locations. These are the employee IDs, and we have generated the respective keys using the mode operation. For 200, the key is 2, so we will store the employee ID 200 in location 2 of the array. Similarly, 189, employee ID 189, it generates the key 0, so 189 will be stored in location 0. That way all the employee IDs are stored with respect to the key generated by this function. Suppose I wanted to search the record with employee ID 206, then I will apply this mode operation on 206, taking divisor as 9, and that will generate the key 8. So I will go to location 8, then I can find there it points to this record, and I can directly go to this record number 5, and get the information here. So this will help us to quickly find the records, and it will reduce the search time to order of 1. The discussion so far reveals that the hashing maps a string into an index in the table or in the array. To perform such mapping, we make use of algorithms or some functions, and those algorithms are known as hashing algorithms or hash functions. The basic goal of the hashing algorithm or hash function is to transform a string into a key. Depending upon the way it uses the string to transform into a key or into an index value, there are several types of hashing algorithms. One of the most frequently used method is dividing the number by the number of available addresses in the array and then taking the remainder. We have seen this in the example that we have used to store the record of employee. There what we did, we divide the employee ID with the number of available slots, then we took the remainder of this division. That means we have used the modulo operation. So the address or the index in the table is created by dividing the employee ID with the number of slots available. Then we took the remainder of this operation. Another method we have seen in the storing of strings in an array. What we did there, we divide the sum of ASCII values of all the characters, and then we divide it with the number of location, and the remainder is taken as the index to store the content. And there is one more method available where if we have a number, for example, we want to store the phone number, say 62914521. This way, if we have a number of this type, we then divide it into equal parts, and then we sum up all the parts to get a key. For example, 62 plus 91 plus 45 plus 21, all these numbers are added, and that number which is produced by adding all these folds or all these parts of the number is considered as the key value. And this method is known as folding method, and this is also been seen in many of the application. After adding these parts, if we generate a number which is higher than that of the available addresses in the array, then we can again further use the modulus operation in order to get the remainder, and then to use that one as a key to store data. So these are the various methods which is used for finding the key value, and these are known as hashing algorithms. Let us take a new example. In this example, we are considering the same array with 8 different locations where we can store data. We have an array of strings to be stored in that array, and we wanted to use the hash table in order to store the data so that the retrieval is faster. So for that, we are taking the same hashing function. We will sum up the ASCII value of every character, each and every character. Then we will divide it by the total number of slots, which is 9, and we'll take the remainder. But this time we have changed few words for few strings in the array of strings. First of all, we have Rama. We will calculate the key. That key is computed as 7. So the Rama will go to location 7, and then we will take Neera. We will again calculate the key, and that also sums up to 394, and when we take the mode of 394, it gives 7. But however, at this point, the location 7 in the hash table is already occupied. If the location which is generated by the hash algorithm is already occupied by some other content, then that is called collision. Here it is said that collision occurs. Collision is an unwanted situation in hash table. That is why whenever there is a collision, we need to take care of that collision in order to resolve it. So there are various methods of resolving collision in the hash table. The one method is, when we have generated the key for Neera as 7, this location 7 is already occupied, then we will look at the next available location. So at that time, the location 8 was not occupied. So we have placed Neera in location 8. Then we calculate the key for Venu, and Venu generates 4. So we'll store Venu in location 4. However, for the next word Madhu, for Madhu is also the same key was generated. So since the location 4 is already occupied, so we'll shift that content to the next location, that is location 5. Then comes the Sita. When we generate the key for Sita, it generates 5. Since the Sita Sita cannot be accommodated in location 5 as it is already occupied. So we'll move Sita into next available location 6. Then we again compute the value for Vicky. It again generates 5, so we will look at location 7, but however location 7 is already occupied. We'll go to 8. 8 is also occupied. Then we will go to the beginning. We'll go to the beginning of the array because 8 is the last location. We'll go to the beginning. Then we found that this location is free, so that's why we'll store Vicky here. Then we'll calculate it for Paul. Calculate it for Paul. Paul is in 6, but 6 is already occupied by Sita. Then that's why the Paul will be directed in location 1, because this is the only location available from when we scan the array sequentially. 0 was occupied, then I will then it will go to location 1. Location 1 was free, then it is been stored there. Then it calculates for Matu, and in case of Matu it generates 2. 2 is not been occupied, so we'll put it in that location. And then we'll calculate for Nia. It is 8. 8 is been already occupied, but the available location is 3, so it will store in that location. So the way, this is one of the method of resolving collision. In this method, what we did, we look for the next available free slots after the key. That means if the key generated is 5, if 5 is already occupied, then we look in location 6. If 6 is occupied, we'll go to 7. That way we'll go on. If we get the if we reach the end of the array, then we will start it from the first location again. So whenever we'll get one location, we will put the content. This method of resolving collision is called open hashing. Open hashing. Open hashing means any of the location in the hash table is open for any type of element. But what is the drawback here? The drawback here, as we have understood earlier, the main purpose of the hashing table is to minimize the time complexity of content searching. And we have seen if we can store the individual items in individual slots generated by the hashing algorithm, then the search time is order of 1. However, in this case, whenever collision occurs, what we did not put the content in their respective key locations. However, we have moved that content to some other location which is available. So in that case, the main objective of hashing is not been achieved. Because if for example, if I look for Vicky is supposed to be in location 4 as it is given by the key. But if I go to location 4, then I find that this Vicky is not present there. This is because at the time of storing Vicky, there was a collision. So that's why we need to search all the location after the location pointed out by key sequentially, all the locations to be searched for the content Vicky. That's why the earlier time complexity of all order of 1 is no longer valid in this situation. That's why this is one of the drawback when there is a collision. Collision, as we have seen, that it degrades the performance of hashing. That's why we need to resolve it. So one method of solving that collision we have seen is using open addressing, where we put the data to be stored in a next available free slot if the location indicated by the key is occupied. One problem with this, that it leads to creation of clustering. It may happen that few of the continuous locations are occupied. However, few of the locations may not be occupied. For example, if this is the hash table, and what we did as a result of open addressing, because in open addressing any of the content is possible to store in any of the location. it may happen that the elements are stored in continuous locations. However, few of the locations are blank, and this is called the formation of clustering. So it happens due to the open addressing or linear probing, also known as linear probing, to resolve collision in hash table. So one method to overcome such type of clustering is to use the +3 rehash. The +3 rehash, it says that if I find that, suppose the key generated for any content is 2. However, 2 is being occupied by some content, then what we will do, we will add 3 in this location, that is 2 plus 3, 5. I will go to location 5, 2, 3, 4, 5. Then I'll try to put the new content in this location. So this will avoid clustering, which occurs because of linear probing, and that is one method which has been normally found to be used in many of the applications. There is one more method which is called quadratic probing. What it does, whenever the location generated by the hashing function is occupied, then if it fails, this is called the first failure. In the first failure, it will take failure is 1 to square, then it will go to only next location. If it fails here also, that means there is also some contents already stored, so this is failing for second time, and it will make 2 square, that means 4. So what it will do, it will jump 4 locations. It will jump 4 locations, and then it will try to store the content. If this slot is free, it will store the new content in that location. Otherwise, if it fails, then it will make it 3 square, because it fails for third time. So that way it will try to find location in the power of 2 of the failed attempts. So it is also one method which is used for avoiding the clustering problem in case of open addressing. And the last method that is used for avoiding such kind of clustering is called double hashing. First we find the key, then key is, if the generated key location is occupied, then we will perform another hashing, or we will apply another hash function on the key, and then whatever the new key generated, that location will be used as a location to store the new content. There is one more method used for avoiding collision, that is called chaining or close addressing. In close addressing, a linked list is used to store data, and let us see how it works. First of all, whenever we have any data to store, it creates a linked list. Suppose that we want to store the first word or first string as Rama. It will create, first of all, it will create a node. It will create a node. This node will store the word Rama. This is a node in the linked list. And suppose that address of this element is 100. So 100 will be stored in location 7, because 7 is the key generated by the hashing algorithm. So it will seems that it is pointing to this element, and this is now no more element. Again, when the key 7 is generated for the next string Nira, it will create one linked list. It will put Nira here, and if it is 200, then it will be linked to the previous element. Similarly, in case of Biki, which is the first element, and it is stored, it is the first element that is generated for location 4. So Biki will be created, one node will be created. Address of this node, if it is say 400, will be stored in location 400, and it will look like a pointer pointing to Viki. And whenever the next element or next string Madhu will come for the same slot or same location 4, Madhu will be added here. Madhu will be added in the list which is been pointed by 400 and occupying the location 4. So this is one of the method which is used for resolving collision in hash table. Although it avoids using the place of others like in open addressing, still here if the number of elements are more, then we need to search the list sequentially, and also that will lead to a search time of order of n. So once the elements are not exactly located in the location generated by the hash algorithm, the algorithm or this technique, hashing technique, cannot retrieve data in constant time or in one comparison. There is another problem in hashing. Suppose that when a key was generated, any key to store a content, let us say A, so this place 8 is occupied, then we will look in location 8, then this is also occupied, and all the locations are occupied. All the locations are occupied. In that case, we will not be able to enter the new item in the hash table. That is why we need to check the load factor while designing the table. Load factor, which is computed as the total number of items to be inserted divided by size of the table, size of the array or table. If it is 1, then this problem will not occur. However, if we take the number of items equals to number of slots in the array or number of locations in the array, so in that case it may happen that out of many locations in the array, only few of the locations are filled and rest of the locations are empty. That will lead to the memory wastage. But anyways, we need to compromise one for achieving the other. The hash function also plays a very important role in avoiding collision. So while designing the hash function, there are certain objectives to be kept in mind. The objective of the hash function includes it should minimize the collision, and also the content should be distributed uniformly across different locations or addresses, and it should be easy to calculate. Also, although we cannot totally avoid collision, if collision occurs, then this hash function should help in resolving such collisions. So in this video we have discussed about the hashing technique. We have seen that hashing is a technique which is used for retrieving data in order of 1, provided there is no collision in storing data. Second one, you have also seen that if there is a collision, then we need to resolve the collision either by open addressing or by close addressing. And apart from that, we also need to keep it in mind the load factor at the time of creating the hash table. The success of hashing technique mainly dependent on the hash function, and also it partly dependent on the load factor.